Hello, we are computer engineering students at STSUG. My name is Giorgi Gugeshashvili, and here is my friend Beka Rukhaia. We may all heard about the Apple M1 chip released about a year ago, and honestly, the marketing of this chip is just amazing. Apple promised 2 times faster CPU, and 5 times better graphic performance, which is indeed impressive, and M1 chip delivers such a high performance at lower power consumption, which means better performance per watt. The Geekbench score of a MacBook Air featuring M1 chip outperforms MacBook Pro's Intel Core i9 processor. We will discuss the M1 hardware, and we will be sharing some technical insights on why M1 is so fast and what makes it so different to its competitors. So with this release of the M1 chip, Apple is breaking their 15-long relationship with Intel, and here is why. First of all, it's not a secret that last year Intel had some delays in their chip releases. That's why Mac had unpredictable release schedule in comparison to other Apple devices such as iPad and iPhone. Moreover, Intel seems to fall behind in manufacturing. Now they ship the latest 11th generation processor in 14 nanometer versions, while Apple has introduced the M1 chip in 5 nanometer version. The last but not the least reason, Apple's goal was always to control the entire technology stack from hardware to software. According to Apple, people who are really serious about software should make their own hardware. You know, when you own the entire technology stack from the operating system down to hardware itself, you can optimize all the parts to work together seamlessly. So finally, we see the revenge of RISC architecture, which is now back to the Mac after 15 years being replaced by CISC architecture. ARM, Advanced Risk Machine Architecture, is one of the reasons, but not only the reason why M1 is so fast. At first, how can one make a processing faster? The first way is to perform more operations in a sequence faster. The second way is to make CPU execute more instructions in parallel. To execute more instructions concurrently, the M1 chip uses so-called out-of-order execution. The out-of-order concept is based on finding out which operation rely on which data. Essentially, CPU analyzes instruction buffer to find out which operations can be performed in parallel and which operations are relying on the result of other operations. So they have to wait and they have to be performed sequentially. For instance, let's have a look at the 4 instructions. The second instruction have to wait because it requires the result of the first instruction, which will be stored in the register 1. However, the third and fourth instruction, they do not depend on the results of the other operations. Hence, these operations can be performed in parallel with the first operation. Now the question is why M1 is better. M1 is better in out-of-order executions than, for instance, the Intel chips. This depends on how fast the CPU can fill up the instruction buffer with micro operations. The more operations are in buffer, the higher the chances that CPU will find more operations to be performed in parallel, and the speed of filling up the buffer depends on how quickly can decode machine code into micro iterations. As you can see, in the decoder is the hardware, which is cutting machine code instructions into micro operations and feeding them in the instruction buffer. So the M1 chip features 8 hardware decoders, while AMD and Intel are having only 4, and moreover the instruction buffer in the M1 is about 3 times larger compared to the competitors of the market. We will be covering this part a little bit later in this presentation. But why it is so challenging for Intel just to add more decoders? So what is the problem here? As I already mentioned, Intel uses CISC-based architecture, which is with complex x86 instruction set. In x86 instruction set, the length of the instruction is not fixed. It can vary from 1 to 15 bytes long in CISC-based architecture. as there are more circuitry in hardware. So especially less code has to be written. CISC-based CPU requires less assembly code to perform this same operation compared to RISC-based CPU. This increases the complexity of CISC-based CPU in terms of pipelining, especially in the decode step. So manufacturers can't just simply put more decoders since it's a lot of complexity to split up each stream of bytes in the instruction within the decoder. On the other hand, every ARM instruction has a fixed length of 4 bytes, which means simply a decode and greater parallelism. That's why Apple was able to increase the number of decoders to 8 decoders. This is what allows the M1 cores to process twice more operations compared to the Intel CPUs at the same clock speed of 3.2 gigahertz. Now, Beka will continue the presentation.
Hello guys, now the question is what makes the M1 faster than other modern processors with more cores? We know that larger GPUs and larger memories, traditionally desktop computers, consist of many different specific application chips such as CPU, memory, or connectivity. However, Apple took a different path here. The M1 chip contains all of these chips built in one silicon, which means that the M1 processor is a system-on-chip design, or as it is abbreviated shortly, SoC. SoC concept is well known for mobile devices. However, the desktops and the laptops are historically built from off-the-shelf components, which generates many obstacles and bottlenecks. So Apple had a lot of experience with mobile devices and just simply brought it in laptops and desktops with their new M1 silicon. Another important thing to understand here, if we buy a chip from Intel or AMD, we get a multi-core processor, which means multiple general purpose CPUs in one chip. For a long time, the way to increase chip performance was to add more general purpose cores in one chip. But what Apple done in the M1 chip is rather different. Instead of adding many general purpose cores and memory, Apple packed the whole M1 chip with a number of specialized cores for specific tasks. Specialized cores are much more efficient in terms of power and also in speed in comparison to the general purpose cores. So now let's have a look what is inside the M1 chip. The chip features 8 CPU cores, 4 cores called Firestorm, designed for high-speed processing, and another 4 cores called Ice Storm, designed for power efficiency. It also includes 8 integrated GPUs, which are claimed to have 6 times better performance compared to the Intel's integrated graphics. Also, it contains a 16-core neural engine, which is a dedicated neural network hardware, which is used to accelerate machine learning tasks, such as voice recognition and camera image processing. There is an additional image processing unit to boost image and video quality. The above cores are not using on its own, but also packaging them all in one silicon. This is what makes the new M1 chip so efficient. With the concept of SoC to speed up some process, for instance, matrix multiplication or machine learning, a dedicated co-processor is built in, rather than just bringing in additional complexity. In the existing CPU, Apple just analyzed that their most common use cases and developed the hardware acceleration was for those tasks which was required. This is partially the reason why many people working on video and image editing gained such a great improvements while working on the M1 chip. Because many of the tasks which they do are dispatched directly to the specialized cores within the M1 chip. Another reason why it is so fast is that the M1 chip got so-called unified memory. So it basically is a 18 or 16 gigabytes of RAM integrated in the same package, which makes its system more packageable. So what is special about unified memory architecture? In the past, GPUs they just had to copy all the data from system memory, which is controlled by CPU, to the GPU memory, and this process required much more time and also resources. But now the M1 chip got speedy low latency, which is known as LPDDR4X memory, which is shared pool between CPU and GPU. The advantage here is that for graphically intensive computations, the data does not have to be moved from general purpose RAM to GPU RAM. Rather, GPU can access data in the unified memory directly. It also should speed up video editing at a lot. And for it, now let's have a look on the diagram. Here you can see that the high-speed fabric connects memory with CPU and GPU and to the cache and to the neural engine. It basically means that the other cores quickly can exchange the information by basically having access to the same memory pool. The disadvantage of this memory is that it requires full integration in the package, so the upgrade of this memory is not possible. Larger cache is another thing which improves the performance of CPUs in the Apple's M1 chip. The fastest level 1 cache is actually pretty big 5-core cores, which comes with 192 kilobyte instruction cache and also 128 kilobyte of data cache. It is about 3 times larger compared to the 11th generation of the brand new Intel chips. So what about other companies like AMD, Intel, or Qualcomm? Some of the AMD Intel chips are already some sort of SoC architecture, but since they contain CPUs and GPUs in one silicon, it's going to be potentially a problem for these companies to include more specialized cores in the SoC because they serve a general purpose market. So they would have to align closely with computer and software makers such as HP, Dell, Microsoft on which kind of the specialist hardware to include, and Apple here has a huge advantage because they own the whole stack. Talking of the other competitors, AMD Ryzen chips are still the best in Geekbench multi-core tests, but the power efficiency of those chips is much worse. But anyway, in a single core Geekbench test, the M1 scores the best. It's great that we are getting more and more competition between Intel, AMD, and now Apple comes on this plan in this area. For the future reference, we think that it's great because the chips will become faster and faster and hopefully cheaper because for the users it will be more cost efficient to buy those chips. And also we want to mention that Apple, everyone knows that Apple is a closed company. It does not like to have its code to have his open source code.
We tried to gather more information about this M1 processor, but it is so closed source that this was all the data we could gather and implement in this presentation. Thank you for the attention and bye.
Wish you success.